Hi everyone, this is Suyue Wang. Today I'm going to present our work, RT Mobile Beyond Real-Time Mobile Acceleration of RNNs for Speech Recognition. This is a joint work with Peiyan Dong, Wei Niu, Chengming Zhang, Shenglin, Zhenggang Li, Yifan Gong, Bin Ren, Xue Lin, and Dingwen Tao. So a little bit about me. I'm a third-year PhD student and research assistant in the Department of Electrical and Computer Engineering at Northeastern University, studying deep learning and computer vision. My advisor is Professor Xue Lin. So the background of paper is, as deep neural network has been developed to the most advanced technology in many AI tasks, such as image recognition and characterization, speech recognition, and recommendation systems. Among them, RNN is widely used in speech recognition tasks. As the most representative RNN, GRU, has been achieved great success in automatic speech recognition. In recent years, executing DNN on mobile platforms has become increasingly popular due to the emergence of many high-end mobile devices. However, due to the high computational complexity and memory consumption when executing RNN, real-time reasoning is still difficult to achieve with existing mobile software. Deep neural network acceleration frameworks such as RNN and TensorFlow lead. Even in recent years, the DNN acceleration framework for mobile devices, including MacDNN, DeepMoon, TF-Lit, TBM, and Alibaba Mobile Neural Network can now support RNN acceleration on mobile devices. In this paper, we propose a real-time RNN acceleration framework for mobile devices named RT Mobile. RT Mobile is composed of two main components, block-based structured pruning and compiler-assisted performance optimization. Unlike traditional structured pruning methods used on DNNs, our novel block-based structured pruning approach that can achieve a finer pruning granularity to maintain high inference accuracy while significantly reducing the RNN model size. We also propose several compiler-based optimization techniques to determine the block size and generating the optimal code on mobiles. Our contributions are summarized as follows. So here we introduce details and overall framework flow of the software algorithm scheme to be co-designed by RT Mobile, compression compilation. Compression and compilation are two key steps to fit the deep learning model on the hardware for effective execution. Mobile compression is the most common task for reducing the size of deep learning models and increasing their speed. Compilation is a process of generating executable code from a given deep learning model. Essentially, compilation is the process of mapping high-level operations in deep learning to low-level instructions supported by the underlying hardware. The compilation process plays a key role in optimizing your code for effective execution. We also proposed a block-based structure pruning algorithm to prune the network. The BSP divides the matrix into modules of equal size and then perform structure pruning within each module. In this way, the effective information in each input dimension and output dimension can be more accurate and fine-grained instead of directly retraining or deleting the entire input dimension or output dimension like structure pruning, which achieves a compression rate and accuracy similar to that of unstructured pruning method. At the same time, structured compression format is maintained in each module, and the hardware parallelism of approximately structured pruning is realized in operation with recognizable and optimization strategy of the mobile phone compiler. So this optimization seems to aim to solve three key challenges: improved RNN execution, thread divergence and load imbalance, redundant memory access, and unnecessary zero storage. Our proposed block-based structure pruning is also guides us to design a more compact data structure than traditional CRS format to store RNN weight matrices. This is because within each block and preserved weights only exist in certain rows and columns, enabling to further compact the index array in CSR. The BSPC format also includes a matrix reorder information to match the corresponding input feature map with a weight matrix. The BSPC format significantly reduces the memory footprint and hence elevate the memory bound issued in RNN execution. Our table 1 illustrates the results, including phone error rate and number of preserved parameters of RT Mobile with different compression rate and the compression with other state-of-the-art method, including ESE here, CLSTM, BBS, WANG, and ERNN. We observe that our proposed BSP method can guarantee no accuracy degradation when the compression rate is no higher than 10, which is superior than ESE and CLSTM with both compression rate and inference accuracy. We also observe that BSP can stably keep a high accuracy compared with other methods when compression rate is relatively high. In addition, we use BSP to further prune the network until the rate of 301 and observe that our method can well adapt to ultra high compression rate scenario. Our table 2 presents the evaluation result of RT Mobile's inference time, giga operation per second, and energy efficiency on mobile GPU and CPU respectively. The table illustrates that when the compression rate is higher than 245, RT Mobile can outperform in energy efficiency by about 40 compared with ESE while maintaining the same inference time on mobile. Well, we also figure out the relationship between the inference time and the compression rate shown in our figure 4 here. So the inference time is in form of speedups over on-dense CPU or GPU baselines, respectively, and speedup grows as compression rate increases. The speedup becomes stable when the compression rate reaches to a certain range. When compression rate is 245, our inference time on mobile GPU is as same as ESE on FPGA. To conclude, in this work, we proposed the first RNN acceleration framework for mobiles called RT Mobile. We developed a novel block-based structure pruning algorithm and 3 compiler optimizations to achieve real-time inference without accuracy reduction. Our experiments show that RT Mobile is superior to existing RNN dedicated hardware acceleration methods in terms of compression rate, recognition accuracy, execution time, and energy efficiency. And that's all. Thank you.